Okay, there we go. All right, so let's go ahead and begin with the first example. We have f of x equals log base 2 of x. And for g of x, we have g of x equals log base 2 of x minus 3. My first step is to go ahead and label the two table of values. So this table is going to be for my f of x. This table will be for my g of x. Okay? And from there, hopefully by now, all of us should know how to graph log functions into Desmos. Does anyone want me to remind you how to do this? Okay? Awesome. So I'm going to quickly show you guys how to do this on Desmos. Okay? Here we go. So we're going to go to Desmos. Right here. Give it a second. Okay, and on Desmos, we're going to type in f of x, just like this, equals log. Now, how do I get to the logarithms? Brian, go ahead. The pink, oh yes, it's right here in the first cabinet. All right, then you're going to click on the functions button. You're going to go ahead and scroll all the way down to the calculus portion. And on the calculus portion, you will click and select the log base A. From there, we then type in our log base 2 of x. And from there, you can also identify points of accuracy by clicking on the gear button, clicking on the table. And from there, you have all the points of accuracy that you can obtain. Okay, nonetheless, let's go back here. And we have the following points of accuracy. I did this for you so that we can speed up the lesson. For f of x, we have 1, 0. We have 2, 1. We have 4, 2. We have 8, 3. And for g of x, we have 4, 0, 5, 1, and 7, 2. Now, keep in mind that potentially we could have more points of accuracy, but we only want to work with the ones that we can fit within the coordinate grid, right? All right, from there, we are then going to label the graph that's on the coordinate grid as f of x. This is the original function. Now, luckily for us, it was already graphed on the coordinate grid. So from there, we will then plot the points for g of x. We have 4, 0 right here. We have 5, 1 right there. We also have 7, 2 right there. Our next step is to then identify the vertical asymptote, okay, the VA. Now, keep in mind that an asymptote is what? An imaginary line that we approach, but we never intersect. We get very close to it. You guys will hear more about this in calculus for the limits, okay? So, how do we identify the vertical asymptote? Now, we're going to do this without the use of the calculator. Here's how you go about doing this. You're going to work with the terms within the parentheses. Go ahead and circle them. And we're going to set these terms to be equal to 0. So I have x minus 3 is equal to 0. From there, I will then isolate and solve for my variable x by adding 3 on both sides. Plus 3, plus 3. This will leave me with x is equal to positive 3. Hence, my vertical asymptote is going to be at x equals 3. So on the right-hand side, using a different color code, we're going to indicate that VA, for shorthand notation of vertical asymptote, is x equals 3. Okay? Now, bless you, we're going to sketch this vertical asymptote. Keep in mind that this is going to be a vertical dashed line going up and down at the point x equals 3. Here we go. So we have a vertical dashed line like this. And we're going to label that right there. Okay? Now, we're going to do what? We're going to connect these points and give a rough idea of what the log function will look like. In this case scenario, the log function will look something like this. It doesn't have to look perfect. It's just a rough sketch. Make sure that you put arrows on each end. Okay? Now, we are going to talk about the domain and the range of this function for g of x, okay? So, how do we identify the domain of g of x? Well, we can do this by hand. Watch this, guys. So, we're going to take the terms within the parentheses, okay? No terms outside. Only the terms within the parentheses of the logarithm. So, we're going to write down domain. And we're going to set these terms to be greater than 0. So we have x minus 3 is greater than 0. Why am I writing down greater than 0? Well, because the domain of all log functions is going to be strictly increasing. Okay? It's strictly positive. All right? From there, we will then isolate for our variable x by adding 3 on both sides. This will leave me with x is greater than 3. And this will be my domain. X is greater than 3. Now, here's the thing, guys. On the exam, we're going to have the 3 formats that we have seen before. The interval notation, the inequality notation, and to some extent, we will also have the set builder notation. Okay? So let's go ahead and write down all 3. All right? So let's begin with the domain that we just wrote down. X is going to be greater than 3. Our second notation is going to be the interval notation, which is given to us by parentheses 3, comma, positive infinity. And it makes sense as well, right? If you look right here at the graph, guys, we read domain from left to right. So if we look at the graph, do I have a graph on the left? No. Do I have a graph on the right? Yes, I do, starting at x equals 3. But we do not include 3, right? That's why we wrote down a parentheses, because it's a vertical asymptote, correct? But we have values that are greater than 3, correct? The graph continues to go to the right-hand side, so that's why we wrote down 3, comma, to positive infinity. Then, we also have the set builder notation, okay? Now, the set builder notation looks like this. We have an open brace, okay? I'm using a different color so that we don't get confused. We have, for all x's, watch this, guys. So this is an x, and then there's a bar, a vertical bar right there, okay? It's not a 1, it's a vertical bar. Then, we have x is greater than 3, and then close brace. Okay, so what does this mean for us? How do we read it? Well, we begin right here. For all x's in which x is going to be greater than 3. For those of you that are going to the pre-calc course, college algebra course, you are going to see all 3 variations of the notation. Okay, all of them mean the same thing. Okay, just different notations. All right, now for the range. For the range, it actually turns out that for the range, all log functions have the same range. It's going to be from negative infinity to positive infinity. Write that down. Why is that the case scenario? Well, we know that range is what? Bottom to top. So if we look at the graph, do we have a graph in the bottom? Yes, I do. Does it continue? Yes, it does. So that's negative infinity. Do we have a graph on top? Yes, we do. Does it continue? Yes, it does. So that's positive infinity. Now, besides that notation, we also have the set builder notation. Watch this. We have a brace like this. We have our y. We have a vertical bar. And we have y is an element of all real numbers. Close brace. Okay? Now, how do I read that? You're going to see this in the future, guys, okay? We read this like the following. For all y's in which y is an element of all real numbers, okay? And finally, we also have the verbal description. So we have all real numbers. Okay? There we go. All right, now besides these three notations, we will now talk about the transformation that occurred from f of x to g of x. I need you to pay attention because this part can get a little bit confusing. It's actually quite easy based on our experience, however. So look right here. This is the original function. We have log base 2 of x, correct? Then, down below, we have our g of x. This is the transformed function. We have what? Log base 2 of x minus 3. Any number that's being added or subtracted within the parentheses to x is going to be a representation either going to the left or going to the right. Okay? So in this case scenario, because I have a minus within the parentheses, it's going to go to the right-hand side by what? By 3 units. But if I had a number outside the parentheses, it would either go up vertically if it's a positive or down vertically if it's a negative, okay? So on the right-hand side, we're going to write down transformation. Write this down with me, guys. Transformation. Okay, so we have g of x is translated right 3 units. There we go. Awesome. Questions, doubts about this, guys? Go ahead. From within the parentheses, we see that we have what? X minus 3. So if it's a minus, you're going to go to the right. If it was a plus, it would go to the left. That's it? All right, let's go ahead and do a tougher one. We're going to go ahead and skip example number 2. We're going to go ahead and jump straight to example number 3. So for example number 3, we have f of x equals log of x. For g of x, we have log of x plus 2 minus 1. Okay? Now for this one, guys, do we have the base written down for us right here for example number 3? No. So it's known to be what, guys? If it's not written down to what? It's a 10. Good. Awesome. So let's go ahead and write that down. A base of 10. Now, what is the name of that? If we ever have a base of 10, these logarithms are referred to as what? What are they called? Common logarithms. Good. Awesome. So if you did not know that, please go ahead and put that on the very top that these are common logarithms. Okay? All right. Now, from there, we're going to label our tables. This first table is going to be for f of x. This second table is going to be for g of x. Bless you. And we have the following points of accuracy. We have 1, 0. We have 10, 1 for f of x. Write that down. And for g of x, we have -1, -1, and 8, 0. Now for this one, it only turned out that we have 2 points of accuracy for either function, okay? Not that we don't have more, we just can't fit them within the coordinate grid that's given to us. Okay? Now, I am going to label this function right here as my f of x. Write that down. That's my f of x. Then, I will plot the points of accuracy for g of x, which are -1, -1, which is right here. We also have 8, 0 right there. Now, before we connect these points together and form a graph, we're going to sketch. Let me see if I can zoom in further. There we go. Can you all see that now? Yes? Better? All right. So from there, we're now going to do what? For my g of x, I'm going to take the terms within the parentheses. No outside terms, guys. So even though I have that -1 outside, I do not focus on that. I'm only focusing on the x plus 2 within the parentheses. So I bring this down, and I set this equal to 0. So I have x plus 2 is equal to 0. Write that down. Then I will isolate and solve for x by subtracting 2 on both sides. So -2, -2. This will leave me with x equals -2. And guess what? This is going to be my vertical asymptote, okay? So let's write that down, that VA is x equals negative 2. Now we can go ahead and graph this on the coordinate grid. So here we go. At x equals negative 2, we're sketching a vertical dashed line. Okay? And now we're going to connect these 2 points. Keep in mind that this is just a rough sketch. It doesn't have to look perfect. So we're going to connect these 2 points like this. All right, there we go. Awesome. Look at that. Pretty cool. Okay? Questions, doubts about this, guys? Okay, now I will talk about the domain and for the range, okay? Now, how do I identify the domain? Well, I will use the same information that I used for the vertical asymptote. I will work with the terms within the parentheses. So right here, I'm going to write down domain, and I'm going to set these terms. X plus 2 is greater than 0. Again, the domain for all logarithms is strictly increasing. It's positive, right? So in this case scenario, I will do what? I will subtract 2 on both sides. So minus 2, minus 2. And this will leave me with x is greater than negative 2. From there, we're going to write down the 3 different notations for the domain. So here we go. Here's the first one that we just wrote down. X is greater than negative 2. That's the inequality notation. We might see that on the exam, the multiple choice. William, Nathan. And we have the interval notation, which is given to us by the x value of the vertical asymptote, which is negative 2. We do not include it, put a parentheses, comma, and then positive infinity. Then we have the set builder notation, which is given to us like this. We have a open set, an open brace like that. And we have for all x's, we have a vertical bar there. So for all x's in which x is going to be greater than negative 2. Close brace. There we go. Again, you're going to see this formatting in pre-calculus. You're going to see this in college algebra. From there, we know what about the range, guys? What do we know about range? For all logarithms, the range is what? All real numbers. Good. Awesome. So on the right-hand side, we're going to write down that the range is going to be from negative infinity to positive infinity. We also have the set builder notation, which is given to us by this, the brace y, in which all y's are elements of the real number set right there. And we also have the verbal description, all real numbers. Okay, now let's go ahead and talk about the transformation that's occurring from f of x, the original function, and the g of x, the transform function. So I want you to look right here, guys. Notice that we have x plus 2 within the parentheses. So what does that mean for us, guys? Is that going to go to the left, to the right, up, down? Where is it going? It's going to go to the left by 2 units. Good. Awesome. What about the minus 1? It's going to go down by 1. Good. Awesome. So on the right-hand side, we're going to write down transformation. And we're going to write down that g of x is translated left 2 units and down 1 unit. Questions, doubts about this, guys? All right, so we just did 2 very good examples for graphing logarithms. Do you guys want to do one more for logarithms, or do we want to go to the next page for natural log? Natural log? Okay, let's move on. All right, so let's move on to the next page. Okay, So we have the following. We have f of x equals natural log of x, and g of x equals natural log of x plus 3 plus 2. Now, let me ask you guys this question. What's the base of the natural log? Can someone help me out? What's the base of the natural log? It's not 10. Someone said it. Oh, Lord. It's e. Natural base is e. Okay? So, let's go ahead and write that down just in case you forgot. Okay? So, the base of the natural log is e. So, if you're taking that chemistry class, you shouldn't be passing right now because you didn't know that. Okay? Anyway, again, these are called natural logs. If you ever see ln, it has a base of e. It's referred to as a natural log. Okay? Now, here's my first step. I'm going to label my tables. This is going to be for f of x. This will be for g of x. And it actually turns out that if I'm working with this type of coordinate grid where it's going to the tens, right, I only have 1 point of accuracy for the natural log, or at least this one. I have 1, 0. I have -2, 2. Okay, and now on the right-hand side, I'm going to label this graph as my f of x. That's the original, okay? Then I am going to plot the first point of accuracy for g of x, which is located at -2, 2, which should be right there. Okay? Now, before I jump into anything else, I need to identify the vertical asymptote, okay? So how do I do that? Well, I solely work with the inside terms within the parentheses, okay? So right here, I have x plus 3, and I set it equal to 0. Then I isolate and solve for x by subtracting 3 on both sides. -3. -3. This will leave me with x equals -3. And guess what? That is going to be my vertical asymptote. So let's go ahead and write that down. VA is x equals -3. Then I will sketch this vertical dashed line across x equals -3. Here we go. Just like this. Then I will connect this point with the following sketch for this graph, okay? It doesn't have to look perfect, but this is how the sketch is going to look like, okay? Not perfect, but a good idea of what's going on. Okay, now I can go ahead and talk about the domain. Now, keep in mind that the work that we're doing to identify the domain is if we didn't have a calculator. Let's imagine we didn't even have the graph, okay? So how do we go about finding the domain? Well, I take the terms within the parentheses, and I have what? My domain has to be what? Strictly positive, right? So let's go ahead and write that down. X plus 3 is greater than 0, okay? Now, if I did say strictly increasing, my apologies. It should be strictly positive, okay? So the wording was a little bit off, okay? Nonetheless, we then isolate for x by subtracting 3 on both sides, -3, -3. This will leave us with x is greater than -3. So that's the inequality notation. So look at that, guys. We were able to find the domain without the use of the calculator, without a graph as well, okay? Now we do what? For the domain, we're going to write out the 3 different notations. So here's the first one. We have x is greater than -3. Write that down. We then have the interval notation, which is given to us by -3, comma, positive infinity. And finally, we have the set notation that looks like this. We have a brace for all x's in which x is going to be greater than -3. Okay, now for the range, we're almost done, guys. For the range, we have what? It's going to be from -infinity to +infinity. That's the interval notation. We also have the set notation, which is given to us for all y's in which y is an element of the real number set, okay? Or we have the verbal description, all real numbers. Just like that. William, Nathan. Okay? Now, let's go ahead and talk about the transformation for this one, okay? Again, we're doing the comparison with f of x and g of x, okay? So looking at this, guys, what can I say about the movement going left and right? Do I have any movement going left and right? Yes, I do. So this one's going where? I have x plus 3, so it's going to the what? To the left by 3. And we have a plus 2 outside, so that's doing what? Up 2. Good. Awesome. Let's go ahead and write that down. So we have transformation. Okay? And we just stated it. It's what? G of x is translated left 3 units and up 2 units. There we go. Questions, doubts about this, guys? Questions? Pretty easy, right? Overall, very easy. We have a lot of experience with transformations. That was mostly for the free response portion of the test, okay? Now, we're going to move on to the multiple choice of the test. Pay attention because these questions, at first, they look very complex, but they're actually quite easy to complete, okay? Let's look down below. So I need you to look right here. These are very easy questions, but if you're not paying attention, you're going to be like Mr. Alvarez. You never showed us how to do this. I'm showing you right now, okay? So, Mariana, look right here. So, for this one, we have what? If f of x equals log base 3 of x, what is the equation of g of x? So, how do I go about doing this one? Well, I first select one point of accuracy for the original function. In this case scenario, this point is located at 1, 0. And then I select a point from the new function. In this case, I have what? 1, 5 for the g of x function, for the transform function. So now we ask ourselves, how did I go from the 1, 0 from f of x to the 1, 5 from g of x? What do we see right there? What do we notice? It went up by 5. Good. Awesome. So on the very top, write down up 5. So now, when they're asking me, this is going to be a multiple choice, guys. When they ask you, what's the equation of this, you're going to say what? G of x equals, now keep this in mind, guys. This is a vertical shift going up by 5 units. So should it be inside the parentheses or outside the parentheses? Outside, right? So we have log base 3 of x plus 5. Okay, there we go. That's our solution. Go ahead and box it in. Now, let's move on to the next question. Same idea right here. So for this one, we have if f of x equals natural log of x, what is the equation of g of x, okay? So for this one, same idea. Yes, ma'am? Yes. So for this one, what do? We choose a point of accuracy. So for f of x, we have a point of accuracy at 1, 0. For g of x, we have a point of accuracy right here at -2, 0. So now let me ask you this, guys. How did I go from the blue point 1, 0 for f of x to the -2, 0 for g of x? What occurred here? It shifted to the left by how many? How many units? 3 units. Good. Awesome. So on the very top, go ahead and write down left 3 units. There we go. Now, on the right-hand side, look how we write down this equation, okay? So we have g of x is equal to the natural log of, now we did what? A shift going to the left, right? So that should be a plus. So x plus 3. And it goes inside the parentheses. All right, there we go. That's our solution. Go ahead and box that in. So really easy, right? Do we all agree these were easy questions? You're going to see them on the multiple choice. Okay, Now, let's move on to our last question for today, okay? Now, this one at first, just looking at it, you're thinking, oh my gosh, what is this problem right here? Look, let's read it. All right, if the point 6, 1 is on the graph of a certain log function, f of x, answer the following questions. What point would be on the graph of the following? Okay, now, let me just break it down for you guys, okay? This is the original point, okay? And what we're doing is transforming the graph using this point, and we're helping identify the new coordinate point based on that transformation. Okay, so looking at the first one, guys, look right here. G of x equals f of x plus 3. So this is outside the parentheses, so this is going to be what? Up by 3 units, right? So we have 6 remains the same, but the y-coordinate is going to be what? In addition with the 3, right? Because it's going to go up by 3. So this point will now turn into what? 6, 4. Write that down, 6, 4. Then, for the second question, we have f of x minus 2. What does this do? It shifts the graph down by 2 units, right? So we have 6, 1 minus 2, and that will turn into 6, negative 1. Okay, next we have g of x equals negative f of x, okay? Now, if you ever have a negative symbol in front of your function, it's going to be a reflection across the x-axis, right? Now, how does that affect your coordinates? Well, look right here. This will change it to be x, negative y. So the x-coordinate will remain the same, but the y-coordinate will change signs. So if it's a positive, it will turn negative. If it's a negative, it will turn positive. Okay? So based on that, we have 6, negative 1. All right. Now, for the next couple of questions, pay attention. These ones get a little bit confusing at first. Okay? Look right here. We have g of x equals f of x plus 3. Okay? X plus 3. What does that mean? We're going to, hold on. We're going to the right, or excuse me, we're going to the left by 3 units, right? Now, this is your h value. If it's an h value, we change the sign, okay? So this will turn into what? 6 minus 3, 1. So this will turn into what? 3, 1. And finally, here's the last one, guys. Last one. Look right here. For this one, we have g of x equals f of x minus 2. So what is that going to turn into? A plus 2, correct? So we have 6 plus 2, and the k value plus 4. It's going to go up by 4. So we have 1 plus 4. We do not change the sign for this one. It's a k value, only the h. Okay? So this will turn into 8, 5. There we go. Now, let's go ahead and close up the lesson. So what did we just learn today? Okay, listen up, Bob, listen up. So if you go home, your mom, your dad, grandma, grandpa, uncle, aunt picks you up, and they say, little Bob, what did you learn today, little Bob? Little Bob is going to say, I learned how to graph the log function without the use of the calculator. I learned how to identify the domain and range in 3 different variations. Hold on, ladies. And I learned how to work with the transformations of log functions, okay? All right, so at this time, here's what I want you to do. On your white worksheet right here, I want you to write down due on Friday. Write that down, due on Friday. Now, the 3 graphs that you guys see right here are nothing, okay? They're just telling you, hey, this is the parent function, don't forget about it. So you can skip those 3 right there. They're just telling you, hey, this is the parent function, okay? So work on these problems, okay? But now, on the back page, guys, everyone, turn to the back page. On the back page, when I was making these copies, the little squares did not come out properly. So even though, hold on, even though we can see that the graph went to the left or went to the right or up or down, it's not easy for us to see by how many units, okay? So on Schoology, I posted the original document. So if you go to Schoology, you can see how many little squares there are and so on, okay? All right, at this time, you can work with your partner. You can do it by yourself, your choice. Go ahead and get started.